Testing audio, check, check. Okay, sounds pretty good. Here we go. Ladies and gentlemen, welcome to the Discourager of Hesitancy, where we work on projects at the lowest level we reasonably feel like working at, in an attempt to wage war on over-abstractions, over-dependencies, over-bloat that happens all the time in modern software. Maybe one of these days I'll do a mini talk on that. I've got ideas for about 3 mini lectures, 3 mini talks. We'll go through those one of these days, but for now we've got work to do. So without any further ado, let us bring up our to-do list, documentation to-do, and see what we feel like working on. That's not what I wanted to hit. All right. While we were working on compilers on Friday, another idea popped into my head about measuring code. So that is one thing we could work on today. For the actual project relevant stuff, we have one, two, 3 items of tech debt that would be reasonable to work on. If we let too many tech debt items build up, it becomes a no fun. Plus, tech debt usually are moderately easy wins on a Monday to get things warmed up. So we could work on those 3. Ultimately, we really want to work on storing UV data in our image warehouse. But I feel like we need to start with like a warm-up task. So those are well, let's see here. 3 tech debt items I want to look at. Or we can compute churn as a measurement of productivity. I would be curious to see how that compares to lines of code, just raw lines of code. See which is more reflective. Because there's a problem these days of people making all kinds of claims about how to be a better programmer, and there's the clean code, and there's the solid principles, and so on and so forth. And yet, they can never, ever point to actual metrics of developer productivity. I don't know how they can make such claims with no study, with no data, with nothing to point at. We can't even agree on how to measure code or productivity. So maybe we do churn today and tech debt some other time. Maybe we do tech debt today and do churn some other time. I'm probably not going to recompute productivity until, what, 3 weeks from now? Because I do it on a monthly basis. I don't want to get overly involved in like daily reporting or anything. I just want to see how the month went. I don't want it to influence our plan or our work. It's more informative than guiding. Does that make sense? I don't want to become a slave to the metrics. I just want to see what the metrics look like. Until you've established a baseline, there's no point in measuring anyways. So what do we want to do? I've got 3 weeks to do this, and so maybe we'll save that for another Monday when we don't have as much tech debt. So let's get rid of that to-do list. Let's do some tech debt. This one I really want, And this one I really want. So these two can easily go on our tasks for the day. Yeah, and if we do UV data, this one will have to be resolved anyway. So let's just grab these three TexQuad items and see how far we get. Put them on the list for the day. Week 6. And then we need 2024 07 29 tasks. Okay. 30, 31, 08, 01. Welcome to August this week. That'll be fun. And just stub out our week here. End of week stats, which we won't fill in. We'll just have it ready to go. And that brings us to today. There we are. Okay, so right now, anytime we ask for the world transform of the affine object, we are recomputing it. But our local transform never changes unless something changes to affect it. So I think we want to copy that same pattern of caching our world transform and marking it as dirty until somebody needs it. That way we're not constantly recomputing a world transform based on parents changing until we need it in the child's transform. So the parent will need a list of children. And the child already has a reference to the parent. Parent does not have a reference to the children yet, except yeah, we'll or let me think. Let's throw this in the scratch buffer here. Let's say that I have some root object, which is in one of our affine transform objects. Let's say it has 3 children, child 0, 1, and 2. Let's say that child 1 has a child A and B. Each of these has their local transform. So we can do this. We always need to store a world transform because you don't want to keep doing matrix multiplications all the time, and we need a dirty flag. So regardless of what we do, let's just start with that. Let's open up a shell. Just see where we are. Yeah, journal and to-do options. Good. Okay. Then we're going to open up source, affine. There are a couple of choices we could make. So far we have transform. Oh, okay. Local transform, world transform. Oh. Okay, okay. Let's do this. We're going to change the name from M transform to M local transform. Oop. Okay, so we'll have to be a little careful applying that in this file. Nope. Yes. Nope, 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 nope. This one. Yep. 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 Nope. Nope. Okay. Data. We don't need this. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Oops. So close. 1, 2, 3, 4, 5, 6, 7. Okay. Let's just get a couple of temporary variables in here. Double x equals underscore transformed rectangle.x. Then just call it position x, position y. Now let's just shorten up our code a bit here. Get it lined up. Okay. Rebuild transform. So let's go rename that. There we go. Is transform dirty? This is all related. So this is local transform dirty. Need to rename that as well. Let's move parent to the top. That's probably the easiest one. And then is local transform needs to be at the bottom. Okay. So we've renamed some things so that when we create this world transform side of tracking There won't be any name collisions or ambiguity. So file. Let's do a full clean build. Well, I'll get my beverage of choice ready. Actually, I got my beverage of choice ready already. But you can get your beverage of choice ready. Ugh. So for those tuning in, what happens is I start streaming and I will stream of consciousness talk about whatever I'm doing until somebody pops into the chat in Twitch. I will try to remember to read the Twitch, the chats out loud for those on YouTube or whatever following, or Rumble following me. So yeah, until somebody pops into the chat, it's stream of consciousness. I find it's hard to keep up a conversation when nobody's in chat. You get what you get. So I do have an error. Because unbelievably, all right, fine. We'll make you a float. I don't think that changes anything. Okay, one thing we do have to do is I would like it bounded between 0 and pi. If 0 is less than theta, theta is less than or equal to constants. What do I call it? Lowercase pi. We could do f mod. I don't know if f mod is more efficient than just looping. I'm not too worried about that right now. Maybe we come back and revisit with performance question. Is f mod faster, better? To bound data. Let's put theta back to double. Why not? Float. Float. Wow, can't type today. Just warming up. Float. Do I not have a... That's fine. Got that one. Single float. Float and float. Okay. Semicolons. Okay, in here, float theta equals this. Then we can clamp theta, then m underscore theta equals our new theta. Boom. Same to do here. Okay. Make sure we're still up and running. No warnings, no nothing. Good. Wow, this one's an interesting one. Here's one of our new letters. Wow. Uh-oh. Privy. There we go. Okay, everything is working just fine. Perfect. Okay. Put our journal. Roll transform caching and groundwork. Rename ambiguous local transform members methods. Renamed define members methods disambiguate local world transforms. All right, Piece one of the puzzle. Part two of the puzzle. We need all of these for the world transform as well. Okay. There are nope, we're just gonna do it this way. This is fine. Score is world transform 30 equals to false. Rebuild world transform. And we're going to return underscore world transform. Okay. If we change our local transform, we have to update our world transform. So that's true of move, center, rotations, scaling. And then we need to tell our child objects that they also need to be updated. Which is a concept we've not yet built into this class. So we're going to cheat. We're just going to say there. Need an array of pointers. There we go. Which means X children plus index. Make them all null pointers. We can add a helper function, add child. It's probably going to be complicated enough if underscore children at index is equal to null. Then added becomes true. And we found a spot to put it. M underscore children at the index equal child and break. If not added, that is an error. We did not give us enough space. If we run into problems, we can change it to a linked list. We can change it to vector. Whatever makes people happy. Doesn't matter too much right now. But find add child. Not enough room. Okay, that's part one void. And there are 2, 3 objects, 3 components we use, which we need to add child, so that's fine. Set child world transform dirty. Actually, set world transform dirty. Sure. Underscore world transform is world transform. And that is that. So everywhere above where we did this, we can replace that with set. That was it, set. Set world transform dirty. And lastly, rebuild local transform, rebuild world transform. And really, we want to steal basically that code. If our parent is not null, where we get our world transform, we can make this a const reference, which means we're no longer returning copies. These are now the same const reference. Okay, clean and debug. See what we've broken. Redefinition. Oops, okay. Get this done. That'll be nice. It means if you change your local thing, your world set gets set as dirty. When we ask for your world, it will ask the parent, hey, what is your world transform? And it does not necessarily propagate that calculation all the way up the chain or down the chain. Last piece we need to do is update our 3 compounded types. The button, the button element contains a color quad batch. The text box has a color quad and a text element. And the spin box has 2 buttons and a text edit element. So that compiled. Oops. Let's make that a little more readable. Okay. So I said first thing is button. We have our color quads. So add child color quads. Add child text. And these do not take ownership of it other than the passing of transforms. That is button text edit. We have a text and a color quad. Come on. Okay. Last but not least, spin box. Integer spin box, I guess. Needs these 3 elements added. That should do it. Everything we need should be good to go, working and done. It should be a much more efficient treatment for world transform. That is probably true. So let's go to where we defined that. Put that in protected. So those 2 are going to go above rebuild. Right there. One. Here we have a typo. And build it. see if everything runs, and it does not. Hmm. This is null. Somebody called its child set transform, even though it's null. So let's go to here. Oh, if it's equal to null. Ha ha ha. Good old typos. Inverted logic. Always wonderful. That'll work. Perfect. Oh. Sandbox. Play. Okay. Interesting. Okay. Everything but B and Y. It's like bound. Perfect. Okay. Everything is working there. Settings. Oh, that's tech debt we need to do. Let me write a note on my tech debt there. To do tech debt. Text, edit, cursor position is off. Is wrong. Is bad. Bad, wrong, off. Perfect. Okay. All right, to our journal. Let's not do that. We know we only have 3 children right now maximum, so let's go to here. Let's not make it 8. Let's just make it 4. Let's put a good error message in here as well. Add child. We can add remove later if we need to. It's not exactly rocket science. Currently only modulus D children supported. That way I remember what's going on here. Like I said, we can replace this with just about anything. We can add more operations. None of that's rocket science. So if you're like, why haven't you implemented remove? And why doesn't it take charge of the child element and so on and so forth? Because right now I don't need it. I add abstraction when I need it. That has bit me less often than the number of times I've implemented abstractions that I then no longer needed and ended up fighting against. So, fun times. Okay, let's just make sure it builds. Quick test, then we'll log it. And we'll save our work. Added children array max 4 to start and dirty lag and rebuild world transform. Here. So that's done. Parent tells children about world transforms that are dirty. Store our world transform per fine so that we don't recompute. That is a memory versus computation trade-off I am willing to make. Right now our game does not have that many elements, so it's not like we're running up against any kind of RAM limitations. So I don't care about the memory usage. Is that it for that one? I think so. Fine now has children and world transform is cached and lazy computed. Only when we need it, we get it. Which honestly is only about once per frame. So, not too bad. Okay, next item. So right now a find.rectangle. So this is our locally transformed rectangle. I mean, I don't even know if this is useful in most cases. It's all about the full world transform. But is anybody actually using it? Except for text. But we set the rectangle, we don't compute it from the text. Let's take a look. Let's go into source, ref-r dot rectangle. Exclude their dependencies. So find provides the rectangle. This is definitely not what I was looking for. I want to know if anybody references it. So let's escape that. Hey, grep, come on. Low effort Z online. Welcome back. Good to have you on the stream. We're doing a little bit of tech debt, some easy warm up for Monday, then we'll dive into some more interesting topics. Just things I left undone that didn't matter too much at the time, but are going to start mattering soon. We have to have the quotes around it, or else it won't work the way we want. Okay, this is better. So we're looking to see who actually calls rectangle. None of these are rotated. If I do everything but the rotation, I mean, let's just add the change in the way that we've thought about it. Minus our center. So if we have a 100 by 100 box and the center is at 50-50, then our X position will be minus 50. So that's correct. And it's only the transformed rectangle we don't care. We care about the raw rectangle we don't care about. This move by should be fine. Set center. Slightly trickier. We're gonna have to add the old center back in and then subtract the new center. I think that's it. So if we go from, let's say that the rectangle is at 0, 0, the center is at 50-50, then we want to set it to 25-25. That means that the rectangle will draw with more of it on the screen. So it would take 50 minus 25, and it would add that. Gonna finish this. Probably will be back. Cool. Doing compiler today? No, compiler was Friday. Honestly, we had pretty good turnout for compiler, so maybe I need to do that more days a week. I don't know. Let me know if you want more compiler. Like, we're at the point where we have all the data in and we can start processing the regex pattern to the NFA. So it's kind of a good time. The title then. Oh, yep, nope, you're right. Dang it. I always forget something. Oh, let's see. Let me get a better title up there. I forgot to do that. Okay. Hopefully that's fixed it. Could do draw a rectangle. Um, 0 minus x, 0 minus y. So we take the new center position, the old center position, and that's going to move it by some amount. If I take the old minus the new, so this is 50-50 minus 25, then we move this in a negative direction. I think. This shouldn't make much of a difference. Anything we're doing right now. But it will be nice when we get around to some other tasks. Everything's looking fine. Yeah. Okay. Okay. So let's mark that one as done. Okay. Now, this one is preparatory to the UV work we need to get done anyways. And I would also like to check it against TexQuad, TexQuadBatch. Also check color quad, color quad batch. Okay, so this is going into the sandbox. And we need to add one of each example. Okay, TexQuad, color quad batch. And not batched. Okay. Because what I really, really want is consistent UVs or color point positions. So like if we say color quad based on a rectangle, so it's all, nicely aligned, x, y, x0, y0 should by default be the lowest, the upper left-hand corner. We want that to be consistent here. We want the UV textures to bring the texture UVs to bring in the images the right side up and to be the same. Because that is groundwork for the next big task. So we're at 1 hour in. And okay. Okay, so we verified this one, that's fine. This one shows up magenta, just like it should. M underscore TexQuad dot set rectangle to be, we can go with like 400. Go with like 10, 400, 100 by 100. Set texture. To the doe.png. That's the easiest one to tell if it's right side up. So that should provide a good comparison there. Where are my color quads? Set quad rectangle somewhere. And there. Okay. Color quad dot set rectangle somewhere. So one thing we want, color quad. We have set color, but it sets the color in all four corners the same. So you want to be able to set each color to each corner to a different color. 2 and 3. And we will need to do the same thing in TexQuadBatch for proper analysis. So colorquad.cpp, set color, like an extra space. There, easy, and set colors, C. There, even easier. Anything I didn't do here looks correct to me. So color quad batch, to properly analyze this, we'll need to do a similar thing. Set color sets it for all quads. Set quad color here, set quad colors. Still all those. So what I suspect is that there's very few times I'm actually going to want to call this directly, but it's useful for debugging. So we're going to steal all of this, put it all in here. Copy this, copy that. Set quad color at quad index 2C 2 3 4. And now in here, C0 1 0 0 0 0. One, 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 one. Two, two, two. Three, three. Okay. Nothing significant should have changed. Except for here. Oh, there we go. Right. Did not do that. Okay, so let's do this. Let's do 410. 100 by 100. This one will be at 5, 20, 10, 100 by 100. Then set quad colors. Okay, we want to set all the colors for the quad. Okay. Our color will be red and green at the very top left corner. The next corner, I guess, will be a cross. So let's go with red, not green, so that'll just be red in the top corner. Then we come down to 255 down, and then back across 0, 255, 0. We will see where all those actually happen. But we do want it to be consistent. If it's not consistent, the next part of our work will not make much sense. Okay. Sandbox goes up, of course. Maybe I need to do a clean build. Doesn't hurt. We will just see what is what. One thing I did want to mention in to do discarded tasks, meaning we don't need it for this project. Maybe we can do this later. I had one. What was it? Shoot. I don't know. If it comes back to me, we'll add it. Okay. Sandbox. Okay, so everything's loaded up. We forgot to add it to our render function. And underscore color quads render color quad dot. What was it? It was a good one. We did not change this rectangle's position at all. Why didn't we? Oh, we're using the default. So this one should be let's go with 400 120, 100, 100. Let me make this one smaller, 50 by 50, just so I can distinguish it easier. This one doesn't matter. These rectangles are all different sizes. Okay, so here's our text quad. Here's our batch texture quads. Here's our batch color quads and our batch color. Not our batch, just our color quad. So looking at sandbox.cpp, these colors are yellow top left, red top right, black bottom right. So we're going around clockwise from the upper left-hand corner, and then to green in the bottom left-hand corner. So that makes sense. Do I add that note somewhere? Let's do that. Let's just add a color. Colors applied from top left corner and going clockwise. So that is consistent, which is good. Because then you can plan. Okay, so there's one. In TexQuad, which I guess we should. What we have is this quad has these indices 0, 1, 2, 2, 3, 0.
People!
He found his ping pong ball that he was hitting around this morning. And then TexQuadBatch. Indices are applied 0, 1, 2, 2, 3, 0, 0, 1, 2, 2, 3, 0. So the indices are applied the same. Okay. This could be a problem. Oh, wait, no. If it's 30, then we compute our new x's and y's based on the raw rectangle. And that's all fine. And we have, in theory, top left. Oh, interesting. Look at the other one. Oh, Those are UVs, which you do want to look at, but first, not set quad corners. Actually, we do have to look at set quad corners. X0, XY. That should be the top left. Okay. So 0, 0 is top left. X1, Y0 should be top right. X1, Y1 should be bottom right. X0, Y1 is bottom left. So these quad corners are also specified in that same order. Okay, and the TexQuad. Zero, 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 negative y. Okay, so this may be where our UVs get off. So this went from the top left corner down, then across, then up. So I bet that's the difference. Because if we look at our UVs, here, this is not the same as the TexQuadBatch UVs. So it went 0, 0, 0, 1, 1, 1, 1, 0. And here it's 0, 0, 1, 0, 1, 1, 0. I'll bet that's where that rotation happened. So, all we have to do to untangle this, so they're the same, because the UVs have to be the same in both uses, is where we set our quad corners by convention. Coordinates go around are from top left around clockwise. So this is the problem. Which I guess actually only really happens here. Vertices are for comp. Okay. Which is correct, but in TexQuad, set the rectangle during render. Okay. We go top left. Top right. Bottom right. Bottom left. Okay, which means this UV has to be in the same order as this one. So 0, 0, minus 1, 1. Oh, no. 0, 0, 1, 0, 1, 1. 0, 1. 0, 0, 1, 0, 0, 0, 1, 0, 1, 1, 0, 1. I think that will keep our UVs aligned. Our vertices will all be in the same positions relative to each other, given a rectangular definition. Obviously, if you define your rectangular coordinates on your own, that will not matter. Okay, and the textures are all right side up. whether it's a single texture quad, the UVs match, the vertices match, these all match, everything by convention. Top left corner, clockwise. Done. Okay, that is done. Where are we at? 130? That wasn't bad. Journal. Vertex UV ordering. Color quad, color block batch. Verified in sync. TexQuadBatch. Found vertex definite from rectangle not consistent, hence the UV mismatch. Reordered and UVs now match. Convention. Rectangles rectangle vertices specified top left first, then clockwise. Boom. Let's see here. So this is done, which means we need a new task before we commit all this. Our tasks. We could fix the text edit cursor position. We're an hour and a half in. We've got our warm up in. We're good to go for the week. But I don't like that cursor floating. But it also doesn't matter because that's all in settings anyway, so it doesn't affect us. So I think it's this. This is a big task. Might take us a couple of days. Two different ways to specify it. We want a third way, actually. Tiles. And it will be tile width, tile height. Default UV, and we just did this, so TexQuad, it's going to be 0010, 0010, 11, and 01. Yes. Enum in warehouse, verify range per image. Okay. So that's our list of things to do. So is that it? Rectangle vertices specified top left first, then go clockwise. Okay. That looks like a good thing. Status, add. Let's go sandbox. Texture UV testing. Let's comment those out for now. We can leave them in. We're going to be testing UV stuff anyways, so. So maybe vertex ordering and texture UV testing. We'll leave them in. Down here in render. Okay. Let's make sure I haven't broken anything real quick. Rider, hey, how's it going? I'm good. How are you doing? Welcome, welcome. So far, we had a couple of tech debt items we've been chasing, just as a warm up on a Monday. But now we're going to get real serious about UVs. Okay. So here was what we were working on most recently. The batch texture quads, their UV mapping was rotated relative to the single texture quad. We don't want that. We want them to be the same. There are certain efficiencies you get out of having a single quad. There are certain efficiencies you get out of having a batch of quads. And then the color quads and color quad batch. We wanted to make sure that we have a good convention. The convention is when you specify colors or UVs, the vertices are always top left corner going around clockwise. So they're all now consistent. All of these are right side up and in the color order expected. So that's what we just wrapped up. And we're going to pick out our next set of tasks. Vertex order now set. Top left, then clockwise. UV is now consistent as a result. Boom, done. Writer, UV, okay. Do we need to have a discussion about UV? We can do that. Ready? Let's go to Scratch Buffer. Scratch Buffer. When you define a texture to fit inside of a rectangle, okay? What we're going to do is we're going to have something like this, la la la. You give it some XY coordinates for the corners, and of course it's going to be a little silly with me. But what we actually are passing to the GPU are, and I don't remember which direction I draw these rectangles anymore, so maybe this is not consistent with my actual representation in game. I'd have to go look at it again. That would be okay. Let's not draw too many. Let's make it a tall, skinny thing. Okay. So when we specify our vertices, we specify a vertex. Let's call it A, B, and by convention, I'm saying C, and then D, okay? So when I specify, for example, a color quad, the quad looks like this, and I can set a color at A, a color at B, a color at C, and a color at D. And for every point inside those triangles, it calculates an interpolation between those three colors, right? So that's why we got the yellow here, the red here, the green here, and then the black here. It interpolated those colors across those triangles. Okay? So in UV coordinates, it's a little bit trickier because each of these vertices has a position, right? 0, 0, X is 1, 0, maybe it's not 1, I don't know, it doesn't really matter right now. X of 0, Y of 1, and 1, and 1. Okay? Those are the XY coordinates that we're going to draw this rectangle at. So the question becomes, if we have a texture, so let's get this, let's get this, this is our texture. The question is, how do we interpolate a color in here given a color in here? Those are called UV coordinates. So what we do is for each corner, we say what the UV coordinate is, right? X, Y, X, Y. Maybe these are, 100. Oh, except these are 0. Sure. No. Try to at least be consistent here. X of 100, Y of 100, X of 0, Y of 1. There we go. So those are our XY coordinates. We also need for each vertex a description of how to get a value out of this texture and choose the color that goes here to interpolate. Shouldn't 1, 1 be B? 2D textures have coordinates U and V since X, Y, and 0 are reserved for 3D space. Yep. Shouldn't 1, 1 be B? It doesn't really matter. So the order I specify these vertices in doesn't matter. We have Y pointing down. Yes. So in OpenGL, the bottom left-hand corner is considered 0, 0 in screen space. That's fine if you're doing 3D and I don't have to worry about certain things, but when I'm working in 2D, I prefer to work in the same space as other 2D programs, where the top left-hand corner is my 0, 0. So I'm using a camera transform to flip my Y upside down, and then I have to negate it. So I've decided on the convention of this is my first vertex, and I go around clockwise from there. So that's just a convention I decided on. I use the screen camera to flip things for me. So in this case, it's probably not your conventional OpenGL program, but that's just the way I specified those coordinates. So your UV coordinates might look something like this. If you want, let's see here, give them some arms, right? So if we want this little guy to draw in here, I have to describe how to how to map this vertex, these coordinates, these 3 coordinates, into this image. So what would actually draw here is something like a long O. He wouldn't have a neck. He'd still have a plus. Minus. Then you'd have a leg on one side of the line and a leg on the other side of the line. Maybe something like that. Okay? 0 Y down, 0 X to the right, and A is origin. Yep. For now. like I said, if we switch into a 3D world, I'm going to abandon the screen space coordinates being different, except for when we're rendering a UV, like a user interface layer. ABCD is the whole game screen. No, in this case, ABCD is just a rectangle we want to draw to. We could draw to the whole screen. In fact, we're doing that for the game scene where the bookcase, the blackboard, and the table are. That's one image, and we map it to the whole screen space. But this one is just, let's draw a picture on the screen of some dude, right? So UV is like this. Now, we can do some fun things with this. For example, let me just finish making these two align. Texture, here's our quad. One thing we can do is we can make one texture contain a whole bunch of things, like a tile set, right? So you could have your vertical wall, your horizontal wall, your fireplace, your typical grass texture, your dirt texture. You can embed all of that inside of this in little tiny areas called tiles. And each little tile would have its own UV coordinates that you would use when you're rendering a box, right? So you say, here's all the textures I need to render my background for this 2D world. And instead of like 0, it would be 0.1 and 0.1 for if we had 10 tiles by 10 tiles in our texture map, in our texture, right? And maybe this one would be at 0.2, 0.1. I don't know, it doesn't matter. But we can actually take fractional pieces of this image and put them as part of our rectangle. So now I can specify the whole screen space, the whole world space, as a whole bunch of UV coordinates, a whole bunch of XY coordinates, and one texture for the tile map. That's one use. We can do other things where we can flip the image upside down by just changing the UV coordinates, or we can mirror it left, right, without having to do any changes to the vertex buffer, to the vertices, just to the UV textures. We can crop this texture. We can also pack texture, like sprite animations in here, where each of those little boxes I talk about is an animation stage. And so we can change the UV texture to walk through those different areas and replace the UV, but not the texture, right? So we just say, hey, play the next frame of the sprite animation, and it's all coming from one texture. So UV coordinates are very powerful. Yeah, it's just a way to map the current rectangle into the rectangle we want to draw. So that's it. Does that make enough sense? So right now, everything we do assumes the UV coordinate is the whole texture into this rectangle. We want to break that because we want to be able to do tiles and sprites. And we'll actually get into an example of the tile use to make a new button. Because right now our button is crap. That was the first thing we built pretty early on. It needs to be replaced. So when we fix the UV coordinates, the button will probably be the first thing we fix. So, okay, cool. Yes, crash course and UV coordinates, they're not that hard. And it's always in the percentage of the width and a percentage of the height of the image. So it should always be between 0 and 1. That's just the way that everything works. I'm trying to think if there's anything else I should mention. Yeah, feel free to drop questions. Always happy to answer. Okay, so back to our journal. So our UV data in the image warehouse. What we have is I've so far embedded 4 textures in here. One is the orangey yellow one is the green eggs, one is the full map background. What's the fourth one? We go to assets, images. Oh, and then the books and the bookcase. Those are another one that we embed. So we've embedded 4 textures. So there's 4 chunks of data. We have the width and the height for each of those textures. Then we have a way to look up an image given a key, and we have a way to look up the key given the image. So what we want, and this is not the place to do it, this is a generated file. We're just going to spitball a little bit here. We're going to have something like static void get UVs, or ooh, interesting. Maybe we do apply UVs for a given texture index, image index. Enum class UVs, UV keys, UV names, UV something. We'll think of something. It'll be very clever. And we're going to have the first one be default. That will always be 0. Then maybe it's like image, or maybe it's, you know, for our button, we want to specify the top right corner will be an enumeration in our here, top left corner, bottom left, bottom right. So these names will come from the UV data we're going to embed in our file. So if we go to our journal, where I said, hey, here's the we want to specify a UV, here's what you look it up with, and here's the actual UV. Okay. Top left, bottom right. Something like that. And then this will also generate out image 1 only. Then maybe something else. Maybe there's a sprite 01 equals 5. And that's for image 2 only, which we're only putting in here for our reference. But basically, some of these enumerations are not going to work for every image, except for default. Default will always work with any texture we give it. That's my plan. Why not pragma once? I don't know. Every time I start having to add pragma once, it means that I usually haven't thought about my dependencies well. I've run into cases where what I thought, the things that pragma once should fix didn't get fixed, so I still had to work through it. So I just kind of stopped fiddling with pragma once. I can put it in again if it makes you feel better. But one thing I've found is, one thing I do is I try to keep my code as C-like as possible in case I want to downport it to C. So if I rely on pragma once to fix it, not all C compilers, do all C, actually that's a good question. C support, I don't think pragma once, I think it's a C++ thing, isn't it? Oh, in C? Okay, so it's supported in C, maybe I could use it. Is non-standard but widely supported. So by widely supported, it probably means everybody that matters does support it. So, but I haven't needed it yet. It hasn't untangled anything for me yet. So again, we only add things as we need them. So this is what we're aiming for. So we're going to output this. Somewhere in here we'll probably have apply UVs. So we need basically a bunch of addresses to floats. Float pointer, U0, U1, dot, dot, dot. We're going to have to pass in eight of those floats. And it'll apply those UV values. So then what we'll need is We need to know for each of these entries. So in entry UV's start index will be an array of entry count entry UV's count. So we'll always be able to say, hey, I want the bottom left corner on this image, and it'll say, is it between the start and the count index for this item? And it'll be able to throw errors or warnings if we're trying to use a button reference instead of a sprite reference or vice versa. And then we just need float m underscore UVs, and that'll be entry count by 8, right? 2 UVs per, well, it's 4 coordinates, and each one has an X and a Y. So we'll have entry count number of 8 element arrays to store the actual UVs. I think that's it. I used to watch a C++ guy that always uses fancy features. It was complex, hard to read. It's not standard in case you're on Borland. Yeah, Borland. That was like the standard back in the day. So C++, this is part of the problem, is it has all these features, but it's become so big and complicated, and because of reverse compatibility, they never remove any syntax. So it's just so big and hard to manage that everybody works with their own special subset of C++. So somebody might write something with this special cool templating thing that honestly nobody else uses, and then you try to read their code, and honestly everybody in C++ has its own flavor and is of varying difficulties to read and understand. So I try to keep it as simple as possible. Yeah, rice cooker. Let's std rice cooker. Is that a thing? And nothing useful coming up. I mean, there are some nice features in modern C++. I really like the functional. I like lambdas. I like, I'm trying to think what else. They did add regex finally. There are some things in 23 that might entice me to upgrade, specifically with format. There are times when I wish that the old C format was a little bit more powerful, but so far I haven't run into a strong reason to upgrade to all the new features. So let's get some notes here. We need. Let's go to journal. UV and image warehouse design. Oh, the other thing we need. One more thing. Static const char star m underscore UV names. Actually, this is going to be static, so UV names of UV count, whatever that is, it doesn't matter. So we need enum class UV name, or just name? Yeah, UV name, which will always have default equal to 0. Oh, index and yeah, there we go. UV name of UV, and the default would be default. So if we never specified it, just always grabs the default one. So we don't always have to specify it for simple uses. Default equals 0. always returns these ones. Boom. Okay, so that's one thing we need. We need apply UVs. We need these 4 things. Range checking. Default always allowed. I think that's it. Private. And public. So publicly, all we're really adding is 2 things. One is the enumeration, and one is a request to apply UVs that are apply the UVs to something. I think that's it. As far as the design goes. You use this for formatting my strings in C projects. Taking a look. stdarg, stdlib, stdio. Format string format, blah, 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 buffer. Length equals VSN printf. Yeah, exactly. So, yes. So if you look at actually my logger, let's see here, source, which I've been copying around to projects forever. That's I guess we don't do string formatting that way, but yeah, we pass around the VA list all over the place. So yeah, we do the same thing. We even wrote macros to. So let's see here, where? I'm trying to think. So literally VA list args, VA start, write my code, and then end the args. Yep. Exactly. So yes, I see that you and I are on similar pages there, FitWriter. Screw strip white space 98. Ooh, this should be a fun one. Generalizing overloading for C++ 2000. Oh gosh. Okay, a whole paper I gotta read. Nice, nice. Overloading separate forms of white space. This comment is considered a single character for overloading purposes. Overloading missing white space. Oh my gosh. Wow. Yeah, I'm gonna have to read that. That's whew. Overloading white space. Oh my gosh. So there are problems with C too. I'm not gonna say that I'm not completely happy with C, so everything has my complaints about it one way or another. Okay, so la la la. I think this is the full design we need. So we're going to go. So we're going to go into Tools, Embed, PNGs. And unfortunately, we wrote a whole lot of reusable code, which means we'll have to unwind all of that quite a bit. This is no longer a key value file. It's going to be more complicated than that. Well, shoot. Okay, all right. We can do it. So we cannot read a key value file. We have to be smarter than that. So let's go into common. Read key value file. We're going to write our own. Read images file. And it cannot return something this simple. It's going to have to be more complicated than that. Can't just be pairs of strings anymore. So an image now. We have a const char key path. We're going to need a file now has a list. I guess we're going to use std list because why not? Definitions. So we need a way to define those. Struct UV definition. We'll have a char key, the thing, that. What else does it need? It needs a mode. Because we want to be able to handle UV with vectors, UV with a rectangle, and then a tiling or sprite sheet writing one. Okay. We're going to make this simpler. Our format. Anytime we can simplify our format, the better. UV tiles, given a pixel width and height. So all of these will be in pixels. We'll compute the UV based on the width and the height. I think that's what we need. Does that make sense? Okay. So we need an enum class UV type. Just a moment. Okay. So our UV type are UVs, UV rectangle, and UV tiles, I guess we're calling it. Sure. So UV definition has UV type. Then it can either have UVs. We could union this. And UV tiles is literally just a 2-element one. So tile, give me a width and a height. We'll compute the rest. Is that everything we need? So we're going to return image definitions. Let's just use list. Image definition. I really don't care about the performance of this piece. I don't call it that often. Let's see here. I always feel bad writing parsers for formatted data. Preemptive optimization eating away at me. Yep. I've become convinced that the right way to do some of this stuff is to just hack together terrible parsers, and then once you know the whole file specification, then you write a better one. So we're dealing with crappy initial implementations, and we're fine with that. All of this goes away for now. Just want to know if this compiles. Read images file. Given the, what was it? We hard code this in because we don't care. Probably have to return result. Yeah. Okay. Oh yeah. Compile, make, build, target equals, embed, PNGs. I don't think I can do it that way. Shoot. All right, fine. I'll look at the make file. Make, build, target. Okay. File. There we go. Union definition needs a semicolon. Wow. Going after struct either. Okay. Okay, it compiles. Hooray! Mickey Maven, I have a very hacked together one. I don't like reading whole lines, so each line will have expected value, and for ints I have a buffer that's max size of the expected value. And then I iteratively remove the leading zeros. Oh, low effort ZZZ, I didn't see that one. Yeah, I wrote a bit, just glanced at the source code of the upstream project, and they did the same. So I'll probably keep pushing this time. Haha. So we're building on Fridays this compiler. Some Fridays, maybe not all. We'll see. And we're gonna have a tokenizer generator and a parser generator, which we will switch to using one of these days, but we're so far from being able to use it. Have to tokenize at some point. Well, and what we're doing right now is you can see, maybe you can't see, where is it? Is we're doing fscanf, right? This is not the best way to tokenize anything. So yeah, this is not great. Like I said, I have plans for the future, but we're not getting bogged down in implementation details on something that's run so infrequently. This is run once, and then all my images are in. And then if I change the file a little bit, then fine. So, it'll be fine. So let's get a word. We're going to open our file. That's fine. We'll check things. Fine. While true. Okay. First thing we're going to do every time is we're going to say, give us a word. Make sure we actually read a word. Otherwise, we're done. And we cannot do this. In fact, we cannot do this or much of anything else. This is almost all not useful. Nope. Yeah, we're gonna have to do a lot of work here. Okay, if stir comp, I guess we need C string to not include string comp. Wow. Oh, it's the function I want, not C string. There we go. If stir comp the word equals one of the ones that we defined here. If it's UVs, then we're going to do something clever. If it's UV rectangle, and if it's UV tiles, I don't remember what I called it. Yep. Okay. Otherwise, assume this is a new image. Does list, let's see here. Yeah, my issue with fscan is very lenient, so I have to expect comments. Yep. The format, oh yeah. Then it says if it looks remotely like data, it's data. Well, one of my go-tos has been just read a line, and if it starts with, if you like white space, trim the front, and then see if it starts with a comment character or two, then you move on. If it's an empty line, you move on, and then just everything is line-based parsing. Like that seems to be one of the easiest parsers to write. But I'm not even allowing comments in this file format right now, so doing the same. Yep. Well, especially with something like Python, it's like you read the whole file, slap it in there, split, and go, or you can do you can read all the lines in Python as you go. The trim is very easy to use. It's not efficient, but it sure is easy to get something up and running, which is usually where I usually start with prototyping a project in Python, just because it's so low friction from idea to something showing on the screen. But, okay. So if it's UVs, it's going to look up std list. Do I have reasonable access to the tail, or can I only get at the head? I never remember this stuff. I have to look. Push back and place back. Pop back, pop front. What if I don't want to pop? I just want to look at it. Or do I just go with vector? Do I just go with vector? I guess I go with vector. Fine. Again, I don't really care about the efficiency of this, so it doesn't matter. Overthinking. Oh, it's almost time for my snack. Result dot in place. Wow. Okay. Back. Result dot size is C++, whatever. Dot key and path are the two we care about. Key equals our word. This is, I know it's not a string equals, don't give me that. We'll get there. Dot value. We will have to fscan another word. Invalid image definition or key, whatever, which will be good. This thing. Okay, so we place back a new one. We set the word. Okay, let's go ahead and do that. Third copy, destination, then source. Why, I don't know. I kind of know, but doesn't mean I have to like it. Okay, so we get the result index key, and we can break it. Maybe we pop. Result not pop. That index, or pop back. We don't want to do anything with it, it's probably invalid. Otherwise, result at index dot path, copied from word, stir copy. Okay, so that'll get us our file name and our path. And we're going to ignore those for now. Are we still using list? It doesn't matter. Okay. So way up here, if we read all that, images, we're going to just run a quick test. Index less than image defs dot size plus index. Log note modulus s modulus x, which would be image defs subindex dot keep dot path. Let's see how that's going. Okay, fine. Expected something. Oh, semicolon. Always good to put in semicolons. Star shell dot tools. Embed. What is it doing? It knows I'm in there. Dot slash embed pngs.exe. Images. Okay, so it's reading them. I got my key. I got my valet, my path. Next up, UVs. But it's time for restroom break, and I'm gonna grab a snack. So I'm gonna be back in just a minute. Okay, and we are back. What are we up to? So we're reading the key, and we're reading this. So everything else should work as before. Oops. Except we want to be able to specify 3 different kinds of UVs. Let's start with okay, so here's one question. We go back to our image warehouse, and we have this UV count. Well, that's not quite right, is it? We need to know how many UV indices to add. All the different kinds of inputs we have are all going to boil down to this. So it doesn't matter what kind we parse out. We're all going to write the same thing every time. Same format. And some of these might actually be 0 and 0 entries. This will always be at least 1 because we always have default. Okay, so I don't see anything that's going to be like a 0 empty array that will cause us problems. I think we're good. Okay. So let's just get through reading these things in. So let's go to images. Let's have the do not contain one. Let's have UVs. Where's my example? So we need to parse out the name. Bookcase. Table, and none of these are going to actually be real. Don't worry about that. And chalkboard. And this will be 4 points. 0.0, 0.5, and remember we're starting at the top left. Oh, 0. Bookcase probably starts at 0, 0.5, 0, then we go down 0.5, 1, and then we come back to 0.0 at table. We're going to say that it starts at 0.5. Let me see. .5. We're basically starting in the center of the image. Then we're going to go over to the right of the image. Then we're going to go down. And we move back to the right. I'm going to say the chalkboard is very similar, except it starts on the upper half and goes down half the screen. something like that. Okay, so that'll be the UV's test case. Books will contain UV rect. It'll have a name, left, and it will be 4 values. X, Y, width, and height in UV coordinate terms. Right will be at X of 0.5. Everything else the same. Tiles. UV tiles are going to be a simple width and height. So 10 pixels by 10 pixels. I guess we could specify it like this. Okay. That's, oh, these will be in pixels, so that's fine. Which means these decimals are not helpful. I want these in pixel space, not in UV coordinate. So 1024 is 512. 512, 0. On the y-axis, it's going to be 768 and 768. Okay, so 0.0, well, let's just change 0.0 to always be 0. 1, 2, 3, 6. This one, we're going to change 0.5 to 512. We're going to change 0.5 to, oh, what is it? 350, 384? 384. 768, 350, 380, 384. Yeah. 2, 3, 4. Oh, no. We'll come back to those. And then 1.0 will be 1024. And then 1.0 will be comma 768. 1, 2. So that's all in pixel space now. That should be usable. Okay. So 005.5. I don't even know how big the book is. So width, we're just gonna say it's 100 wide and 50 tall. Starting at pixel 100. And another 150 tall. Basically cutting the books. If we assume the books are 200 by 50, we're just cutting the books into left and right. UV titles 10 by 10. So it's just gonna go row by row, 10 pixels by 10 pixel chunks and create those enumerations for us. Okay, so we have enough stuff to get started in this part. If we get UVs And we need to read in 8 values. Means we have to take well, firstly, if result.size equals 0, log error, cannot define, or must define UVs after a file key path pair. In other words, we have to have been in here and at least put one thing in before we can parse out UVs. Same thing everywhere. Okay, so that's problem 1. Otherwise, result at result dot size minus 1, result at index dot UVs dot pushback or in place back mention that dot type E, and then that stuff. Okay. Oh, we're getting there. We're getting there. Type of UVs. I guess we can read in the key here. UV definition for image. I think we can't find the word, which it'll be something like that. Otherwise, string copy into this thing dot key from word. Here, we don't have to worry about any of that. Actually, yeah, no, we don't need the key at all set. Yeah, so just get this far. Actually, we can't. So there's all those numbers out there we have to read in. Not copy. Data. UVs. That's the next piece we need. Data dot rectangle. Data dot. So we do have some questions, but we can, maybe we need one more type. Okay. We need a reference to our data. They are all represented as arrays of floats. And now we can count equals f scanf. We need the format, or we need the file. Where's f scan? File. Modulus D. Modulus D, parentheses, space. We need 1, 2, 3, 4 of those. Quote, paren. Now it's going to be data plus 0, data plus 1, data plus 2, data plus 3, data plus 4, data plus 5, data plus 6, data plus 7. Six, 7, 8. Yep. Okay, this one only needs 4 of those, so this 1, 2, 3. The next one only needs 2. Because all we need is a width and a height. Okay, is that it? We should be able to print some things now. For size T, oh, let's see here. Index image index. UV index 0, UV index less than image defs at image index UV's dot size plus UV index. Okay. What else do we need here? Killian?
You're staying outside, you're gonna wait your turn.
Okay. This one has to do with UV definition missing name. UV definition missing UV values. It's the main one propagated through all 3 branches here. We could probably make this better now that we kind of know what it looks like. UV definition missing rectangle values for the image. Missing file size values for image. Okay. One last piece here. Const char star UV type names. 3 of those for now. UVs. UV rectangle. UV tiles. Okay. Now up here, we should be able to print some stuff. Let's see here. What's our width here? 1, 2, 3, 4, 5, 6, 7. 7 is our widest one, I guess. Modulus 7s, which is the name. No, which is the kind. not equal to UV type. UV tiles. UV type names at static cast 2 integer this thing bracket thing else actually we should give a prefix key. What am I saying? One more journal. UV tiles prefix. Yes. Yeah, so we're still going to read in the name. Here. Yep. Okay. So I don't need this at all.
Ready?
Okay.
Can I have that?
Thank you. Okay. Where am I at? Dot. What was it called? Key? Yes. Okay, let's see if that reads out the way we would expect. Has no UVs. Oh. Fine. UV index. UV index. Okay. We're going to simplify. Simplify. We're just going to have UVs, and it's up to type to tell you what you need to know. Oh, that's true. We are taking only integers, not floats. Um, called data. Please not data. Okay, let's see how we're doing. Cannot convert integer to float. Oh, of course. Int data float. Yeah. One more time. Int data. Okay. How are we? Oh, so it compiled. Now, if we run it, something is wrong with my formatting. When I'm logging things out. UV's bookcase is not indented enough. So it is eating up more than it should, which I think means we have to put a space Huh. And I have to think about that a second. Oh, well. But That's one of our problems. UV definition, missing name or image. Playmat. So maybe the square brackets just need to go. I kind of like the square brackets though. Hmm. Definition missing name. Hmm. Okay. UV's definition missing the name for that image. So playmat does not have a key. Okay. What if we put a white space in? Just to try it. So weird. Okay, maybe we need spaces before and after things. Good. Oh, maybe this will fix it. There we go. Which probably means don't need all these leading and trailing spaces here. Okay. Images. The dough has none. Playmat has 3, and they are UV definitions. Oh, we did not print those all consistently at all. Oh. That is slightly odd. Oh, this is the modulus 7. Maybe we should make it -7. Oh, that's better. Okay, perfect. We do have a trailing square bracket somewhere. Oh. I think I see. Yep. Well, that is just silly. So because chalkboard, it does need that trailing space after. A little bit silly. We could remove all the square brackets. Just remove the square brackets. They're causing me more issues than I feel to deal with. Which means the embed pages anywhere doing things like that. All right, almost there. Okay, that's looking better. Good. Then, lastly, the data should be fine since it did not fail any of them. Switch. Case UV type of UVs logs those things and breaks. Well, let's three. Star data equals this data. Zero data sub 1. Data sub 2. Data sub 3. Data sub 4. Data sub 5. Data sub 6. Data sub 7. Ooh, okay. UV rectangle. We only need the first 4. E2, E2, 2, 2, rectangle. Tiles. Size. Okay. Is there anything else we need here? Let's see how we're doing. This for clause does not guard. I beg to differ. Misleading indentation. That is actually fair. That may fix most of our issues. Okay. We have informations. Those look like numbers. Okay, so I think we're reading it all incorrectly now. So this line has been replaced. We need to write out the header. Just a moment. Okay, so we're reading all that data in. What used to be the right header function needs to be updated with something different. Image warehouse. We do not need the width and height specifier because this is a custom function. It's no longer general. And we do not need this size passed in because we will get all of that from the image definitions. Image defs. Oh. Okay, fine. So let's go to common right header. We'll make our changes to that. We have a file name, we have a class label, we have a definition label, and then we have image defs. Okay. So right header is going to have a lot of similarities to this right header, except for all the things that we've already talked about. So we're going to just grab all of that. Okay. Let's see. So anywhere we talk about size mode, we only have width and height. Okay, we talked about several things we want in there. Besides, well, we can get that from journal. Journal has what we need. We need this enum class, uname. Okay, back to that. The first one is always default. Oh dear. We have to ask ourselves the question if, oh goodness, I want to pre-compute the number of UV int UV equals 0 for int image index equals 0, image index less than something. defs.size plus image index. UV count plus equals. That's it. So if UV count greater than 0, then we write a comma, otherwise we don't. In here. One, two, three, four. 1, 2, 3, 4. Let me think. UV count with UV total. UV count equals 0. We have to detect when we're at the last UV. What else? Need UV's sub UV index key. It's going to equal UV count plus 1. Modulus S, I think. It's getting to be a little bit of a complicated one, but I think it's not too bad. We get the name, we get the number. Now the question is, do we need a comma? So if UV count is less than UV total minus 1, then we have to put a comma, otherwise we don't. And the last question is, if this is UV index equals 0. So it's the first UV for that image. Then we want an output. A comment. Otherwise we don't, but the comment comes in two parts, so we actually do it like this. That will be the image name. Or the image key. Image definition calls it the key. We only output new line if there was a comma. We need one more of these. Okay. Now we said the other public thing we add is a function. This. Those are the two public-facing things we have to add in this case. Let's just see how far that gets us. So here we're logging everything, it's fine. Write the header. Oh. Yeah, there's no way this is gonna run the way we want right now. Because we have this entry count, which is really just image defs size. Let's see what happens. Yeah, I've seen worse. Okay, expected something before an if statement. Oh, what language am I in? Good question. Who knows what language I'm in? And then this one is a modulus d expects integer, but 3 has type. Fine. What? That's a long unsigned. Jeez. Okay, no warnings. Run it. And what we're going to find out is what's in image warehouse .hpp. Okay. There is no new line at the end of this. or commas. But this is the general idea. And apply, oh, is there a dot 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 there? Because I'm a doofus. I copy pasted where I didn't need to. Okay, couple things forgot. U0, U1. Two, three, oh wait. V0, U0, U1, V1. That's what I'm looking for. Two, two, three, three. Okay, the commas and the new lines are not quite right. If the oh, it's E3. Sheesh, less than. Oh, there's my commas. 4, 5, 6. Oh. All right, we're just always then have to put that bracket on the new line. This one here. Means this last string goes away. File, run it. Right. Image warehouse. Shoot. Oh, no, it always gets to the new line. That's the new rule. We got to add it back in. So there we go. Image warehouse. Boom. Hey, that looks usable. Bookcase 1, table 2, chalkboard 3, left, right, GZ tile. Perfect. And we have apply UVs int index, which is the image index. UV 0, 1, 2, 3. And then the UV name, if needed, will default to default, which is index 0. Okay. Nothing there that I need to rethink yet. Okay. In the journal. Need to think about that. Privately, we need to add these 4. Right about there. Now those are in, except for that. Start count UVs. Entry count 8. Post char star. You know what? Oh, no, I can't. I can't. It's fine. Okay. I think those are the excess. So UV count needs to be set. UV total. Now it's UV count. Okay. Okay. So our UV class is coming in fine. We can see which images they're intended to belong to. Apply UVs. And we forgot some new line characters. Right here, right there. New line, new line, new line. Okay, Savage Lord Severus, welcome back. How are you doing? You've had a weekend to recover. Hopefully you're feeling better. Hopefully you found something already, but I know it's a tough market. Entry count, 8, UV. Okay, so a couple of things to tide you over while you're working, but yes, you're not paying me enough to do admin. I assume you didn't use exactly those words. Well, good. Good. Everything here is copacetic. We could. It could be really, really. No, we'll do it this way. Okay. You did use exactly those words. Well, you're probably done contracting for them then. still, sometimes it feels good, right? Therapeutic. Alright, I already overwrote. Let's see, that's my logging. We write the header. Write source. Ugh. Here actually is the saddest part for me. I think. May not be that bad. Go to common. Write source. Let's just copy everything for now. Ooh. Oh, text new line. And print binary line. And not write text. Not write bin. Just one right here. That's all we need. Right source. Instead of a list of files, we do that. Instead of, oh, we don't need the size mode. That'll be easy to refactor out. Because we're only dealing with bytes here. Or no, we're only dealing with width and height. How did the parser go? Still working on it? Oh yeah, it's gonna take a while. Well, so we're parsing the file out now enough that we can get the regex pattern, which is what we need for the next step. So yeah, maybe we'll do that on Friday. If enough people whine and complain, maybe we will do more compiler stuff rather than the once a week. But right now we're working on some game development with no game engine, so we're writing our own. We're not writing an asset loader. Well, not. I guess it's my asset pipeline, but it's not really much of a pipeline yet. So let me see. All of this should be fine as is. Where the big issues are this function after get index. So that's going to go in here. Class table. So yeah, unfortunately right now everything is in a broken state until we get enough stuff written out to our image warehouse file that will compile again. Right now, it will not compile. Dum-da-dum. Okay, so that's there. We need the. We've got these things defined. Under here. This is where all this is going to go. And actually, this one is probably the easiest. Class label. Um, right here. That's where that'll have to go. Basically, that stuff will have to go there. You ever seen the switchable comments? Oh, nope. I don't know what you're talking about yet, so switchable comments. Nope, I don't know what you're talking about. Let me know. Give me more details or a link or something. Let me think. UB total. We'll count up the UB total. Okay. So it's like you have two versions of a big chunk of code you need to switch between regular. You can do this. Okay. Okay. Is code block 1 active, code block 2 commented out? Yep. Look at the very first, it'll comment block 1 and enable block 2. Okay. Yeah, I've done similar things where, let's see, what would I do? I would do things like this, this, yeah, and this one, probably do things like that. But that one needs just pointing me out looks simpler, although I do just wish languages would support. Seriously, put that there and that there. Yeah. Which really, oops. Yeah. Okay. That makes sense. So you're saying slash slash 1 slash star slash. We delete this one. Almost. What's the last piece? Forward slash, forward slash. Like that. Okay. Alright, I see what's going on here. That's kind of clever. No, I don't think I've ever seen that before. Very clever. I'm trying to think. So, one of the things that we will do in my tokenizer generator is to support nestable block comments. So I'm trying to figure out what it would do with this. I don't think it would work with this. This is abusing the fact that comments are not nestable. I think. Oh, we might have to try it out. Yeah. Okay. Cool, cool. Index to key map is defined in here somewhere. Here, index times 2. All right, they're making me sad. This whole class is, or not class, this whole method is a little bit ugly. It's less than UV total. Okay.
You asked her. I'm not even here.
Okay. The lads are so active sometimes. So this is not correct. So what we need to do is mark where we're working. Image index. There, right there. For each image, we go through each UV. Equals bracket. We're basically going to print out image definitions at image index dot UVs at UV index dot key. I think that's that. Like that. It's index 0. Okay, I see what I'm doing there. Okay, so UV names should be good to go. It's these four we will need. Oh, this is already defined, so that's fine. These two aren't that bad. This one will be the tricky one. Going to lurk for a bit. We'll leave stream open. Cool. Yeah, no, if you have any questions, let me know. Otherwise, I'm just going to stream of consciousness here while I'm working. Always happy to have lurkers. The only thing I'm missing from getting affiliate at Twitch is average of 3 users who watch. So, unfortunately, I stream too early in the day, I think. I got a couple of hours every day where there's not that many people watching. Drags my average down. So, feel free to lurk. Okay. So class label. Equals. Actually, these all need to go. Yeah, in this general region. This one is the tricky one. All right, let's just see how that turns out. Files is not declared. That is correct. Right, source does not need size mode. Yes, I know files was not declared. This is the key to index map. Image definitions dot size plus index. File, not files, but image definitions. Index dot key. And the index. What is that index for? Modulus S is whether we put a comma, space. Then we put in the key and the index. Index plus 1. The first thing we do is actually this, but for default. At 0. Default will always be 0. Then we fill in the rest, index plus 1. Oh, no, that's not the right one. What am I doing? This is the image name, not the UVs. Okay. Image definitions. Index. This is the index to key map, which is going to be at image definitions dot thing dot key widths and heights. Image definitions dot size. Image definitions dot size. Okay. We get this done today. I've got another. I mean, I'm gonna go an hour. Go another hour. We get this part done today. We could be in really good shape. Definitions index plus 1. Oh. Dot path. Index f name key temp size, temp width, temp height. I think that output should work fine because this is the actual piece that matters. Image definitions not size plus plus index. Printf widths. Image defs dot size. It's 1. Image defs dot key. All right, let's just see how that looks. Index was not declared. I beg to differ. That's true. True. Why is index not declared? There's no. Oh, there it is. UV names. If something. First UV equals false equals true. First UV. Which means we have to put in brackets. I can't get away without brackets anymore. First UV equals false. files was not declared. I agree. So close. Sizes. Okay. That was a lot of refactor. Let's just do a clean and build. No warnings. Run it. Image warehouse. Things as expected. Image, nope. Image warehouse dot cpp. Yes, I know it's a big file. Don't worry about it. That's all good. Okay, apply UVs is not defined, which is fine. I just need to write myself a note. Apply. Here we are. This one, let's put in the content here. To do implement, easy to spot. Okay. Then we've got our key to index map, our index to key map, our UV count, UV names. So close, actually. UV names. That goes away. And here, oh no, it's never first UV. Because the first UV is always one, two, three, four. Default. Is never the first UV. Therefore, it's always comma. Okay, apply UVs to be done. UV names, default, bookcase table, chalkboard left, right, GBC tile, that's fine. Okay, we need to do these two. Those are the easy ones. This one's not even that bad. No, it's fine. Okay, so entry UVs start index. We are so close I can feel it. To do implement. Okay. Now it'll be easily seen wherever we go. Image UV. and UV count equals 0. This is the number that matters. So what we're doing is we're storing what index do we actually start at. And we're always going to start at UV index equals 1. Def file 1, 2, 3, 4. Okay, which is going to be the UV index. UV index plus equals the size. This is obviously not quite right. There, I think that's that. And then shoot. All right, this one gets a little more complicated then. Can't do it the same way. Because I want to see there's the comma. Modulus D, there is a comma. UV index. Um, oh, not UV index. UV count. UV count is the UV count less than m underscore, or no, UV total minus 1. If it's less than 1, we put in a comma, otherwise we don't. And then we get the image index dot key. And a new line character. Okay. Is that everything we need? I think so. Okay. Very similar, except slightly simpler actually. For each image in the image definitions, you'll put a number, except that instead of UV count, it is image defs at image index dot UVs dot size. I guess we do need UV count. Oh no, not UV count. No, UV count is correct. But whether we have a comma or not. Oh, wait. We always have the one default UV no matter what. Okay. 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 For each entry count, we get the size. Nope. This is not right. The UV count. What we want is image index less than image definitions dot size -1. There we go. UV count, whether there's a comma or not, and the string. Size, whether there's a comma or not, and the name. I don't think I need UV count here. Okay, let's just get those two put out. We've got a warning, so let's get rid of that. Integer type int. Warehouse Reload. To do implement, that's fine. UV's start index. So the dough does not start at 0, it starts at 1 because the default is already in there. Right? Default is always 0. And it has no entries, so playmat is at 1. And it has 3 entries, so book starts at 4 with 2 entries, so that's 6, and there's only 1. Perfect. So now we can query those correctly. This one. The first one's obviously the easiest. The first 2 kinds, actually. All right. I think quick restroom break. Then we'll get back into it. Okay, and we are back. Okay, let's check this out. Problem 1, we're missing our scoping operators right there. The first one is exactly what we already talked about. In journal, we have this default, which looks like this. Except looks like that. Okay, and do this as UV total greater than 0 question mark. If it is, comma, otherwise, no comma. We're just done. Now, one question is how much precision do I think I need? That is one question. This one's going to get slightly complicated. So it's probably going to be nested enough that I want to do something like that. Switch some UV index dot type. Case UV type type UVs. Zero point zero 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 with modulus 0.3 F 2 3 4. Same thing for 1.13 modulus 0.3 F. Instead of default, let's see, let's make this a little easier to read.
Daddy, Dad, Daddy, Dad.
Okay. If it's UVs, it's actually kind of easy. Comma, then this thing dot key. And these first 8 are just int data, or no, yeah, int data. And I need the width and the height of the image.
Daddy, can you do this? This, Daddy?
Okay. Sub UV index dot data. Okay. So I need each image's width and height. Where's that width and height get? Hold to me. It's coming from here. Widths. Get width. Widths. Temp width. So I have widths and heights here. Uh, which means I kind of want to move these down below. Or we calculate those. Put UV data. Because now I have widths and heights. So image width and height equals heights sub image. Okay. We do have to ask ourselves this question. We need to fill this in with something if this size is 0. Oops. Output this thing. Let me just mark this as 0. This data should never be used. And it's not default. So modulus S is whether there's a comma or not. Then I need the image defs sub image index dot UVs sub UV index dot key. That's it. Our comma testing is pretty bad though. UV count equals 0. my alarm to tell me it's almost 5 o'clock. But I think we're going to go a little long today. Try and get this working and compiling. Oh, wait. This is no entry count. No, no. Why are we doing this per entry? Is it called UV count? Yeah, this should be UV count. There we go. So there's the names, just right. There's the UV count. There we go. Okay, so we do not have to check if the UV size is greater than 0. We just get that. We don't have to check the else. There is no such thing as an empty UV. Okay. All right. Is U count greater than or equal to UV total minus 1? There we go. Then we get image definitions key as the last thing. Okay. Now we get data. Oh, that's interesting. Data sub 0 divided by width. Data sub 1 divided by height. We're going to get the widths and heights and cast them to floats. Then when we divide, those will become floats. 0.3 FF. What is this double FF? Three, 4. There we go. Two, 3, 4, 5, 6, 7. That should give you my UVs. 2, 3, 4, 5, 6, 7, 8. String for comma, string for name of the UV. I think per image, we're going to do one thing here. If some size greater than 0, we'll put out the name of the file. File given this dot key. Two, 3, 4. There we go. And so that's one case. Another case is UV rectangle. It's also going to output 8 things, but it's going to be a little more complicated. 0, 0 is fine. You know what we could do? Equals data 0 can make this more usable. X, Y, width, height. All right, and we decided we're going to work in a very particular order for consistency. X over width. Height. Y over height. So that's the first UV coordinate. The next one will go over. So X plus width and Y. Then it goes down, X plus width, Y plus height. Then it goes back, Y plus height. Bottom left. I think that's it. Generating code is always so much fun. Okay, the one I haven't thought through at all. 0 and 1. So we have nothing more than a size, a width, and a height. So question 1. UV tiles. And the last thought is UV sprites. The idea being that the tiles are laid out in row and column, and sprites are assumed to all be continuous. Do we add a UV sprites everywhere? It's int x equals 0, int y equals 0. Tile y less than. How did I get that width? Yeah, it's called it width. Y is less than width. And while x actually. We can make this simpler for ourselves. For int x equals 0, x less than width, x plus equals w. For y equals 0, y less than height, y plus h. Int row equals 0, column equals 0. Oh, yes. This actually raises some other issues. Dang it. This UV tiles one, I knew it was going to be a problem. Sort of. Because tiles, sprites. Do we add the sprites thing? Oops. Back to those. Okay, so one place where I'm not sure I like what's going on here. It's not where we're reading it in. Okay, the number, the UV total. Can't quite do it that simply. Because a sprite or a tile map oh, and we can even okay, there's lots of considerations here. Because one of these UVs could be one of the sprite or tile types, which means we have to know how many rows and columns we're going to add. Right. Both UV names we've been putting out are wrong. So we aren't filling out sprite or tile information. I think instead of 10, I'm going to make these like 5 or something. Also means I'd like to do UV sprites. And one more thing. So one thing we might want to do is say, here's my sprites, or my tiles, here's their width and their height. But I don't want to fill up the whole space. I'm only going to have 7. So do we put a limiter in there? We don't have to right now. We can come back and do that later. Equals UV type, UV tile, or sprites. Then you do one thing, otherwise we have to UV total plus equals 1. Okay. There's always something a little more complicated than I figure going in while I think it through. And I think it through when I'm writing my code. Okay. So. Oh, no. Do I need to write the source before I write the header? When I write the source is when I get the image sizes. Okay. I can do that. It's just logging. We write header after source and widths here. That needs to be global. Now the widths are global. We should probably do UV total global as well. When we write the header, we don't have to recompute this because we will compute it here. That's fine. And we compute our widths and our heights in this file. Okay, in that case, we can take widths, let's see here, int row count equals widths sub image index. Column count equals heights of image index divided by data sub 0, and this can be integer, that's great, and 1. UV total plus equals row count times column count. Except, how many times do I use UV total before I've got the widths and the heights calculated? I do, I think it's fine. Okay. UV count plus UV count plus. This one gets it inside here and inside here. Okay. And the name will have to be updated. Row column. This one, we do not need row and column. It is a sprite count. Okay, now where are we at? How's that looking? much closer in some ways. End of each X, column plus plus, the end of each Y. Okay, same thing here. Oh, except we don't have to keep track of row and columns, so that's fine. Okay. UV names. This one. This one is the problem. Let's just see where we're at. I think I've made too many changes lately. I'm losing track. What? Oh, 3. You know, do that. A function definition is not allowed here before, so I've lost a bracket somewhere. Where did the bracket go? We just put it right there. Height was not declared here. Use it. Okay, fine, I agree. Ugh, okay. Fine. We will put all sorts of things around each one. Each UV. Oh, that goes away. For each image. Oh, great. Now what happened? What is this? Okay, that looks better. That's not better. Where does this break go to? Break. There's the switch. Too many parentheses. Getting too complicated. Okay. Run it. Must define UVs after a file key path pair. Huh. Okay. Must define, and I'm afraid. Oh. There's my problem. UV tiles. If probably means now I have an unbalanced parentheses out here. Okay. Okay. Image warehouse dot. Go to the header, because there are some things that are different here now. Except that. Those need to be different. UV name. What's that called? UV name. I don't like it. Maybe UV key. Okay. But then, yeah, 206 UVs. Because the dough is kind of a big file. Although I'm not tiling that one, I'm tiling GPC, which was what? Maybe it's. Let me see how big that file is. Active projects, assets, images. 256 by 256. So each of these tile and sprite mappings. Oh, oops. UV name with UV key. Is images text GB sprites GBZ sprites. Okay, fixed a couple things there. What else we got? Image warehouse header. So we have basically a 10 by 10 tile map here and a 10 by 10 sprite map there. Let's go to, we just want to see something a little simpler. So if we go 50 by 50, that'll be a 5 by 5. $50 by 100, they will look different. PNGs, file. Image warehouse dot HPP. Okay, 26 UVs. We can then analyze 26 UVs. Image warehouse header. Reload everything. That one needs to be implemented. That's fine. UV names. Those all look. Okay, these will have to change. We are outputting default. But these are all looking like they belong. 1, 2, 3, 4, 5, 6, 7, 8. Oh, no F. Nothing has the F in it. Okay. And now we have row 0, column 0, row 0, column 1, etc., all the way down to row 5, column 17 here. Oh dear. Oh, column never got reset. And this comma disappeared, which means we're overrunning our total, which means we're doing something wrong. Okay, we're getting closer. Mid PNGs. Aha. Modulus 0.3f with modulus 0.3 ff. Okay, and column gets reset every time we start over. Okay, run it. Okay, again, the UP names have to be fixed. Okay, Now these all line up nicely. Zero, 1, 2, 3, 4, 5, 6, 7, 17. 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. No. 1, 2, 3, 4, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Okay, so the sprites and the thing all agree. What else? I think this is just about it. Oh, 1.053. That shouldn't be possible. Problem the first. These names need to be in two places. They need to be here and here. Oh, shoot. And it's always just a little bit more, isn't there? Here. That's the widths, the heights. Start. So this did not count properly either. Or here. Okay. Small list of things to fix here. Oh, do I have time? Do I have time? I have time to fix these two. Whoa, whoa, whoa. I have time to fix these two for sure. Oh, come on. Emacs does not do very good with big files sometimes. Okay. Start index here. So this is my problem right here. UV count. Okay. For image with UV 1, 2, 3. Sub image index dot UVs dot size. Switch UV index dot type. Let's see here. Image UV count. Case UV type. UVs and case UV type UV rectangle. Both of those are image UV count plus rake. Not that rake. What is that rake? It's UVs, UV tiles, and sprites. Image UV count. Okay, so I do have widths and heights. This thing. Let's do this. Instead of UV total, it's image UV total. Image UV total. Once we have a UV total. Yeah. UV count, image UV count. Okay. There are more parameters we could put in the tile and sprite, but we're not going to. Okay, if this works, it does not. Run it. We want the start index. And why is that not 18? I think that should be 18 right there. And 100 in 256 by 256. So we can fit 55 times. And 100 we can only fit twice. So that is 10. Okay. That makes me feel less bad. Therefore, we can sort of steal large portions of this. So instead of this,
Yes. Yes.
oh, image UV count comes here. UV count equals 0, or UV um start index equals 1. UV start index. So come on. Start index. There's the commas, there's the key. UV start index plus equals the image UV. Okay, it's closer, I think. Oh dear. Oh dear. What happened? What happened? What? Oh no. Now what did I break? What did I break? This is not a normal break. Why did it not output the whole file? Why did it truncate? I know it's a big file. That's no reason. No, that's no reason. Segfault. 27. Oh, good heavens. Sheesh. Sub image index dot UVs dot size. Permission denied because it's still open. Quit. Okay, okay. Okay. There we go. Ah. Oop. Okay, these are looking better. Size is 10. Make it all the way to this one 6. Then we add 10. There are 10 more, so we should have UV count of like 26 then, right? UV count 26. Good. Okay, so that's driving. Minor correction here, which I know what to do with. Embed PNGs. In here. We're outputting tiles. Plus height, x plus width. Which should probably be applied here as well. Y plus height, plus width. We are going to get this binary data embedded. Hopefully it files when we get to that stage. Yes, I know it's a big file. What do you expect? This is uncompressed binary data. There's our 10, 0, 1, 0, 5 rows worth. 2, yeah, perfect. This is 10, perfect. Okay, so that's fixed, good. This is fixed. Which means what? We need to fix UV count right here, or UV names. So UV names, the enumeration itself. So this enumeration needs to deal with tiles correctly. We are so close to just being ready to compile, but I know if I go too long, I will be sad. Also, why is there this extra comment here? I know why. Never mind. Bed PNGs. Okay, so what we need to do, if I go too long, my file gets too big and I have to split it, and that takes forever. My video file before I can upload it to Rumble. Gigabit limit, or gigabyte limit. So if I go more than 5.5 hours or so, I will have to render out 2 halves, which takes forever, even with no editing. So I think what we're going to do... Oh, wait. Also... Image warehouse. Some of these are outside my range. I would expect Well, what I expect? Maybe it's fine. Maybe I just punched in the wrong numbers. Books, yeah, the books probably. Actually, we can find out the book width. Right? The books were 230 wide, 40 tall. Okay. All right, one. We need to let's log what we got going on here. Implementation of embed PNGs. Almost done. Just some loose ends. One. Verify UV values. Some are larger than one. That could be correct. Two. Enum needs tiles sprite. UV names needs tiles and sprites. I think everything else is correct. I think that's it. Those three things tomorrow morning. And then build test. Now, by default, nothing should be using it, so we'll have to add some code to the sandbox to test. But I think this is almost it. So the fact that we got almost done with UV embedding today, we probably would have done it if we hadn't done some technical debt first thing. Okay, so let's save our work. Where am I? Image, let's see here. UV data almost embedded in executable. Loose ends in journal. Okay. All right, not bad, not bad. I think we're gonna call it a wrap there. We'll pick up tomorrow. Let's see if there's anyone here to raid. Let's see. Okay, looking. Looking. Someone to raid. Maybe this one, maybe that one. Let's see. Maybe. Okay. Yeah, we'll do this guy. Okay. In that case, thanks. Oh, no. Let's see here. Is there anybody worth? Do we have anybody in the chat to raid with? Not really. Okay. Maybe we'll skip the raid today. Thanks for joining. We will be back online tomorrow. We will finish up the UV coordinate embedding adventure. and we will have that tested tomorrow. And we may, as part of that testing, re-implement the button multiple ways with the new UV data and batch texture quads. So, in that case, thanks for joining. I look forward to chatting with you tomorrow. Bye.